Now we got a local speaker for a change. Lukas Kölbl is going to talk to us about automate customer ticket handling from an idea to production-ready model. The first title to actually need 2 lines in the spreadsheet. So we talked a bit about it. It's basically what do you do with a ticket that comes in as a request to your company? What can AI do to automate these things to make your life easier and get the customer a faster answer for the problem they probably already know how to solve. They just need a nice way to explain it to them. He works for Accenture, so they know they get a lot of requests in, a lot of clients to work with. So please tell us about what you're doing with tickets. Thank you very much.
So hello, can you hear me? Yeah. My name is Lukas Kölbl. I'm working for Accenture Digital. My home office is in Vienna. And I'm in the team which is called Applied Intelligence. So again, AI. So we're doing everything related with data science, machine learning, and all this stuff. Today I want to talk about my last project, which I have delivered a couple of weeks ago. The topic is about automatization of customer ticket handling. We'll talk about that a bit later. And also about the journey from an idea to a production-ready model. Because what we are seeing at Accenture is that many clients want to do some kind of AI, but actually they do not know which kind of technology they should use, which use case they should focus on, and so on and so forth. But before we'll start, Mac. It's working, fine. I have a question. So we're AI developers, we are data scientists, and I didn't hear this question up to now, so I will raise it right now. Who of you are developers or coders? Please raise your hand. Okay. And now, second question, who is a Python developer? Okay, a bit more. That's interesting. So last time, R was one more guys. Yeah, so I'm an R developer too. So to give you some background about my CV, I made my PhD at the Vienna University of Technology in time series analysis. So I used R mainly for developing our models. And then when I switched to Accenture, I also investigated a bit in Python, but I mainly focus in R. So let's start. Here I have a classical consultant slide. Many things on it, but many buzzwords on it, but nothing substantial, I would say. So here we have in the middle AI. So we heard a lot of things today, what AI is and what AI is not. And we also have here kind of machine learning, data science, and all these other buzzwords. I also have here an empty bubble, which is for you, so you can insert your specific buzzword, like blockchain or other stuff. And what I want to highlight here with this slide is that the world outside is really, so it's really hard to follow all the things right now regarding AI. So when I moved from the university to Accenture, after finishing my PhD, it was like, okay, I know a bit about math, a bit about R, must be quite easy in the business sector. But then, when I moved to Accenture, I heard stuff like artificial intelligence, I heard stuff about machine learning, and I thought, wow, sounds really interesting. What is that kind of technology? But then it turned out it's math at the end, but with different words. So in math, we are saying we are estimating a model. Here, we are saying, okay, we are training a model. We are having a linear regression in math. We also have linear regression here in machine learning. What is a bit different is a nonlinear regression model, for instance. Quite unsexy name. Here it is called neural network. But more or less the topics and the models are still the same. And the main problem is that many companies are out there who are also confused about all these topics. And I visited a lot of different presentation today, and I'm also not quite sure if each presenter knows what AI is and what is not. So what we see at Accenture, that there are many clients out which want to implement AI. They do not know what it is, they just know that they want it. And we have the current situation here on the left side, many companies that we have a huge reporting layer, we have many Excel macros, which are really horrible, by the way. We have the analysis layer, that means the advanced analysis, you have some kind of optimization, and on the top you have artificial intelligence, or say, machine learning or advanced analytics. So for instance, in the financial sector, we have here the risk department, which are using some kind of machine learning, depending on how you want to call it. And actually, in most situations, you want to transform the company into a data-driven, AI-driven company. So you want to go to the right side. You want to reduce the Excel files. You want to automate stuff. So the idea is to increase the analysis layer, data-driven insights, and to increase the artificial intelligence layer. So when we're talking with the client, they're asking more or less the same questions again and again. So first of all, what are our use cases? We see some image detection use cases. We see some text classification use cases. Are they really fitting to our current business model? Next question is, what is their benefit? And how much will it cost? Of course, are really important questions. And that what we also see is like, when we want to transform to a data-driven company, what are the legal requirements on one hand? And on the other hand, do we have the right data, the right people, and the right technology to live this kind of data-driven company? So as you can see here, there are quite standard questions, I would say, and a couple of talks already discussed those questions. Okay, so what is our approach at Accenture to shape a use case, to shape a business case from an idea to a production-ready model? And here we have highlighted a couple of steps that we're usually doing with our client. So first of all, we're doing a design thinking workshop. It's like a 1 or 2 days design thinking workshop where we are discussing in breakout sessions possible use cases. What I really want to highlight here is a tech infusion. It's like you have an external expert who is telling you something what other companies are doing in the AI sector. So usually if you ask someone from an operations sector, what is your problem and how should we solve it with AI? They will say, I have a problem with my Excel macro, it's not working. But these are not actually the use cases that we want to talk about. So you need some tech infusion external guy who's telling you, okay, what can you do with that kind of technology? The second step is then to create a roadmap. That means within a couple of weeks, let's say 3 to 4 weeks, you want to define those use cases and shape it and to transform it onto a roadmap. So some kind of prioritization is also very important. You should start with the low-hanging fruits, of course, when you're doing this kind of shaping. And what is also really important is the structure of company regarding AI should be reconsidered. So usually if you think about data science in a company, you have here the pyramid, and then you have on the left side a data science team, you have it here on the right side, and also someone in the middle. Are they connected usually? No. If you ask the client, what do you want to do? Then they tell us maybe, they have once a week a call, and I think that's enough. Maybe that's fine, maybe not. But at least you should reconsider the structure here at the beginning. And then what we are usually doing is some kind of proof of value, or proof of concept, or rapid prototyping. There are many words for that. And the idea is to create in short sprints some demos which should give you some insight into the problem and also into the solution. That doesn't mean that we are doing, 2-month prototyping. Then it's not prototyping, it's just a couple of weeks, 1 week, 2 weeks. We also create a prototype in 2 days. So in short sprints, we want to get a feeling which data do we need and how we can solve the problem. At the same time, or afterwards, you should think about technology. I'm always separating between the mathematical stuff and the technical stuff. So on one hand, proof of value, you think about the math, how you can solve it. But then you need some kind of environment to put it into production. Microsoft is also here, so maybe you can do it on Azure or you can do it on premise, depending on your company and how you want it. And then at the end, you should start with the implementation of the first use case. Maybe it should not be the hardest use case, maybe the low-hanging fruit. One thing that I will explain afterwards is, for me at least, the low-hanging fruit. And what is also quite important, the employees of the company have to be made aware of AI. What does that mean? When we're talking about AI, everyone has this picture about a robot in his mind, or a black box, or stuff like that. And for me, at least, the most important part is that at the end, the customer should know what we are doing, why we use this data, why the model does the prediction based on this data. So this is really also some kind of knowledge exchange. So what is also really important to transform a company to an AI-driven or data-driven company is like some kind of rules. So community of practice, for instance. I just can say the things about Accenture. Communication is really important stuff. So not just having calls, but also to have meetings, to have hackathons, because knowledge exchange is really important stuff when you think about data science or machine learning. AI governance. We should have the same objective and the same language. This is really complicated because it's not always the same that we are saying AI, and we have the weak AI and strong AI. I mean, I have no idea what this is actually, but you should use the same language if you talk about the same stuff. Next point is education of business. This is really, for me, a challenge, because if you think about AI, you should handle with realistic use cases. I mean, we talk about self-driving cars and stuff like that, but if you want to implement this kind of algorithms, I mean, it's more or less impossible within 1 or 2 months. So you should focus only on the easiest stuff at the beginning, and then if you have a feeling, and if you have the right people, if you have the right technology, then you can scale the whole business cases too. And which is also prioritized carefully. That means we should have a roadmap, a long-term strategy, with different steps, starting from small POCs, small projects, to middle projects and large projects. And of course, the last thing, leadership, is really important. So if you want to transform to a data-driven company, leadership should also commit to that. And I just can speak about my company, at Accenture. This is really a commitment, and we want to be an AI-driven company. We want to be innovative. So now this was enough theoretic stuff. We want to come to my last project. It's automatization of customer ticket handling. And here we have the current situation. We are in the case of intelligent case processing. Sounds a bit cryptical, but I will explain it right now. So what is the use case? Here on the right side, you have an input channel where you're receiving tickets and emails from customers. So let's think about an online store or a financial sector where you have customers who are complaining, I cannot log in, I have a problem with my login, for instance. So you're getting different unstructured information from the customer side. And what's the current situation? Currently, the agent is reading the stuff and then is deciding what to do based on that information. And the idea is to, I would not say replace, but to reduce the amount of tasks that the agent have to do by, here we have a red black box with natural language processing and machine learning. Sounds quite cryptical. I will explain a bit later what this is. And then, of course, if you have received the information that you need, you can trigger something to reply to the customer. You have to reset your password, for instance. Yeah. So what is here the critical part here? We have a main challenge is combining two different views, the customer view and the company view. So on one hand, we have here the customer who is saying, I have a problem with my login. What can I do? But of course, here on the business side, on the company view, it's more detailed. It's saying, okay, he has a login problem because it's a fraud case, for instance. Or it's a login problem because he entered 10 times the wrong password. So they're more detailed. And the main challenge is here this mapping from the customer view to the company view. So how did we get rid of this problem? Or how did we even find this kind of problem? So the client, which is coming from an FS sector, made design thinking workshop where the focus was mainly on the operations side, so customer care. And here we identified many use cases, and two of them were on one hand this automatization of customer tickets, and the second thing was a chatbot. And as you can see, there's a kind of overlap regarding those two use cases. So we decided to map this whole approach into a roadmap and to start immediately with a rapid prototyping session. So how many of you have ever built a model, so a text classifier? Okay, 10 guys, not quite a lot. But okay. So the idea is here to have, just want to explain the data set that you're using usually. So here we are in the area of supervised machine learning. And usually you use, in the simplest case, let's think about a spam filter. You have the data. Column 1 is the text. And column 2 is the class, so spam or non-spam. And then you have the two different classes with around, I don't know, 100 data points, 1,000 data points, depending on how many data points you have. And based on that, you're training a model, which is then predicting the outcome. So then you're sending a message to the model, and it's telling you, it's a spam case, or it's not a spam case. And actually, we wanted to do the same approach here. We requested the data from the customer side. They gave us, I don't know, 1,000 different data points regarding 6 different classes. And then we trained our model, and it turned out that the accuracy was around 60%. And so we said, this is not quite a lot. So we investigated into the false positives, for instance, and analyzed the data. So what was the message, and what was the prediction? And from our side, it seemed that the model is right. So we asked the customer side and told them, yeah, come on, the data look like class A. Model predicted class A, but actually you said class B. Why is that? And then he said, let me investigate. She took the case, looked in 3 different backend systems, and then she mentioned, it's a fraud case because the fraud counter is high. So as you can see here, the data, the text was not enough, but we need text plus metadata information to get the right combination. So this is exactly what I meant by customer view and company view. And this turned out here, this rapid prototype step. So for me, this is one key component to a successful implementation project. Then in the last phase, we made the technology assessment. So the client decided to do it in the cloud, because it was the first time that they're developing such kind of model, and they wanted to get a feeling of how complicated it is or not. And then at the end, we implemented the whole stuff within 6 to 7 weeks. So this is, from my point of view, the standard time range to implement those kinds of use cases. Perfect. So I just want to explain the old world at the company and then the new world that we have created. So on the left side, we have the old world. So if an incoming email, so customer is complaining, then the first agent is reading this email and is saying, okay, it's written in Greece, so I cannot read it because I just know English and German, so I have to forward it to my colleague who understands this kind of language. Then we fit a topic agent who understands the language, but is not responsible for those kind of use cases. For instance, it is a problem regarding a login problem, and he's only responsible for, I don't know, payment problems. So then he decides to forward it to another guy, the Greek payment agent, for instance, who is solving the case. That means he's replying to the customer. And as you can see here, there are many different steps, and it's super, super not efficient. And on the right side, here we have the future approach that we have created. So the email is arriving at the client. We're doing language identification or language detection so that we know the language. And then we are using language translation too. So we are standardizing the data. We're translating everything to English. And then what else are we doing? We are extracting the product. So the customer is complaining about which product. And then we're classifying the topic. So a kind of 2-step estimation procedure. Then it turns out, okay, a login problem. Then you can split one hand to the correct agent, or you reply automatically. This could be also one possibility, of course. So to give you a bit of feeling what we actually created, here another example. So here we have the incoming email. Now it's in German. Ich kann mich nicht ins System einloggen. Bitte Hilfe. So you also have some kind of typos here. Then we identify the language. It's German, and we translate it. Yeah. I cannot log into the system. Please help. So based on that information, we are doing, in a first step, a text classification. So we have around 45 classes. So we're classifying these texts onto these 45 classes and get a distribution over the classes. So for instance, here we have login problem 80%, sounds reasonable, and 20% account blocked due to a security issue. Based on the text, it makes sense. But then we're attaching the metadata to this distribution, like account status is locked, or login attempt is 10, which is quite high. And another metadata information from the fraud tool, log reason fraud. And based on this new information, we are again classifying our ticket. And here we are receiving a different outcome. Now it's obviously account blocked due to security and not anymore login problems. And as you can see here, if we wouldn't have done this rapid prototyping step, we would just create this box, and this would be our outcome. And this information will be completely lost. So what was our timetable? We had 4 different phases at the end. So in the first phase, we have a ramp-up setup, because it also turned out in the rapid prototyping step that we need to collect the data in real time. So the data is not available, so we have to collect them. And actually, which kind of data should we collect? So we decided we are collecting as much as we can. So we had around 150 metadata fields, which we are using at the end. So here we deployed a dummy model, which we then trained in the second phase. So here we used the collected data, around 1,000 data points per day. And we trained our initial models. So we have, at the end, there were 4 models. So product were a 2-step classifier, and also for the topic were a 2-step classifier. And then we brought this model into production. So this was here at the end. And then one thing which is really important in machine learning is to retrain the stuff. And after 4 to 6 weeks, we started with the phase 3, where we retrained our model based on the new information, based on the new data. And then in the last phase, after we are trusting the model, we can automatize the whole stuff. Of course, not each process, but at least some low-hanging fruits again. So what is the increase of value for the client? Of course, you spend a lot of money, so you also want to get some value. So the first value is a decrease in response time. So due to language translation and case classification, the process is now more efficient. The agent knows at the beginning what this case is about, and he can handle it more efficient. The second thing is that you can also automate specific cases. So for instance, if we do not have enough information, when a classifier tells us, there is something missing, we can automate this kind and automatically reply to the customer saying, please give us your username, or please give us your email address so that we can connect it with the metadata application. The third thing is, for me, one of the main important things, better reporting. Sounds really boring, but the idea is, when we started this project, we had around 300 different classes to classify. And it turned out that we had a special distribution. So the top 10 were like that, and then we had a huge drop to the remaining classes. So we asked the business, can we reshape this structure? And at the beginning, the client was quite skeptical, and then we presented the first results, which were not good. He thought about that, and then we reshaped the classes. And this is also one key component if you're doing machine learning. Not just developing a model, but you also have to adapt the whole process and then put some kind of machine learning on it. Then it's, of course, more efficient, because it's easier to classify the whole stuff. So this is also data-driven insights, and that you know what is your data, how you can manage them, how you can improve processes. And then the last thing, which is really important from my side, is distribution of knowledge. So this is more or less the main task that we're doing all the time, is understanding the why is a key component for AI acceptance. So at the beginning of the project was like, I do not want to spend so much time in the analysis phase, because AI will do everything for me. And then I'm asking, okay, what is AI? There is no AI. I mean, I'm a mathematician, I'm estimating models. Based on the models, you have a prediction. If the data is crap, then the model is crap, and the prediction is crap. And then they got a feeling of what we are actually doing, what is a data science doing. And this was really a key component here at this project. Okay, so here, my last slide, questions. And
right? Good on time. We got about 3 minutes to do more questions and answers. We have a few on Slido, but nothing big. I mean, one of them is just Python or R.
You can also run it on Azure, so.
Or JavaScript, if you want to.
Too, sure.
Okay, since this is a real-life case, any data on AI endangering jobs? How many people lost their job because of your automation? You can also look there. It might be easier.
Ah, great. That's right. Okay, so maybe we should so the main idea, so what was the goal? The goal of the project was, of course, that we are reducing the workload for all the agents. And so there was some kind of forecast of ticket workload in the future, and it turned out that it will explode in the next couple of years because in the financial service and some special client, so the market expectation is going up. And the idea was to have the same amount of agents to get rid of the more customer requests.
And also, I guess, dealing with their mental health because they don't have to ask the same things over and over again.
Yeah, that's true.
I mean, the human should always come in when the computer can't do it any longer, rather than like answering the same question 15 times a day, because that's just depressing as a workplace as well.
And actually, that's also the thing. I mean, it was also the second use case with a chatbot. And I see that there is a huge overlap, because if you have a chatbot, then usually, or hopefully, the clients or the customers will not send an email, but they will use the chatbot. And if they have a more specific question, then they will write the email. Yeah. This is more or less this kind of combination where you can reduce the workload quite a lot. And this will hopefully work like that.
How far down the line is the automated translation into the translation for the agents later on? Like when a request comes in a language they don't understand, is there still a bit of discrepancy, or is there an assumed discrepancy by agents, or do they just understand it once it comes in?
So we have used the Microsoft Translation API, and yeah, it turned out that it worked quite well. One drawback is that if the quality of the text is not as good as expected, I mean, no one is writing a Wikipedia article if he's requesting for login problem. The translation is also not as good as we thought. But I mean, you can also try the Bing translation, you can use the Google translation, and therefore you can use the right API that you want in your system. I mean, you can exchange those components. I mean, it's an API which you can call.
It's also weird to ask in one language and then get an answer in another one.
Yeah.
So automatically translating it back might be a more dangerous thing than automatically translating inside.
I mean, you can also translate the reply, so it's like...
Yeah, but
then you have to
you never know what the exact result is. That's the problem.
That's true, yeah.
As you redefined the classes, how did you get enough labeled data? That should have been quite expensive, as you cannot outsource it.
Right. So this was also one problem where we had to focus quite at the beginning of the project. And it turned out that there were two possibilities. On one side, mapping the old world to the new world. This was one thing. And the second thing was just to remove the data and collect in real time. So this is like a long approach, of course. But yeah, it's like that. So you're waiting for the feedback of the agent regarding the no class. Because yeah, if you use the old structure, it will not fit at the end.
How did you cope with GDPR?
This was also one question at the beginning. And it turned out that if we anonymize all the personal relevant content in the message, then we're fine. So we do some kind of regex, we do some kind of anonymization based on email address and stuff like that. And actually it worked quite well. So this was really also one outcome from our side, how we can get rid of this.
What tools did you use to build such a system in such a short time? What tools did you use to store data?
So we deployed the whole stuff on Azure, but we used R to create our models. And yeah, I mean, the training took around, I don't know, 5 hours. So, I mean, you can run it over the night, so this was not a big thing. And yeah, data depends always on the problem that you have. maybe 2 data points are enough if the problem is quite easy. And it turned out that for our kind of problem, we had actually enough data. So we used for each class, I don't know, but it's like 200 to 300 data points.
Seeing that you now made it work for your client, do you also use automated inbox replies in mail clients? Or do you still think this is a thing? We build these things, but we don't use them. That's the point that I'm making. Are you using these systems now for your own personal conversations, or do you still think it's not big enough to make it worthwhile?
Well, it depends. It is not such an easy question. Years ago, we developed spam filters and stuff like that. Now they're working out of the box. So replying automatically is, of course, quite specific, related to the topic. But yeah, if Microsoft would offer us that in that way, in a handsome way, then it would be, of course, you.
Okay. Well, thanks very much. Thanks for your ticket talk. I hope you learned something. We have a 15-minute break again, and then we get yet another local person to come on stage and tell us more about DevOps.